Welcome to The Explainer. Today, we're jumping into the world of medical AI. Now, in this world, being right is obviously a huge deal, but what if knowing when you might be wrong is even more important? That's what we're talking about. How in the world do you teach a machine a very human trait? Humility.
So let's just start with a huge question, one that really gets to the core of this whole thing. I mean, think about it. In a field like medicine, where the stakes are so high, being 100% certain all the time can actually be pretty dangerous, right? A good doctor knows their limits, they know when to call for a second opinion, but what does an AI do?
Okay, so the potential here is just massive. We're seeing these AI models do incredible things in pathology. Scanning digital slides of tissue samples and spotting patterns that could be cancer. We're talking about diagnoses that are faster, more consistent, and maybe even more accurate. It's a total game changer.
But, and you knew there was a but coming, here's the big catch. It's a problem called domain shift. The best way to think about this is like a self-driving car. Imagine it was only trained on the sunny, perfect roads of California. Now you drop that same car into a Boston winter. The lighting's all wrong, there's snow everywhere. It's going to see things it doesn't recognize and could make a very confident but very wrong decision. It's the exact same thing when an AI trained at one hospital suddenly sees images from a scanner at a different hospital.
And this right here, this just lays out the core problem perfectly. A human expert, a pathologist, they get it. They understand when something looks ambiguous. They know when a case is just plain tricky, and they'll ask for help. A standard AI? Nope. It just spits out a single, confident answer. And that can be so dangerous when it's overconfident but dead wrong. When it comes to patient safety, that's a risk you just can't take.
Okay, so how do we actually fix this? How can we build an AI that's smart enough to know what it doesn't know? Well, some researchers have come up with a really groundbreaking method to teach an AI a brand new skill, basically calculated doubt.
And they call their approach Biscuit. The whole point here isn't just getting the right answer. It's about giving the AI the ability to, raise its hand and say, hey, I'm not so sure about this one. You should probably get a human expert to take a look.
So what's the magic behind this? It's a technique called Monte Carlo dropout. Now that sounds complicated, but the easiest way to think about it is like creating a little committee of experts right inside the AI's own brain.
Here's how it works. For every single tiny piece of that medical image it looks at, the AI doesn't just analyze it once. No, it runs the same analysis up to 30 times. And each time, it kind of messes with its own neural network just a little bit. It's literally like it's asking for a second, a third, even a 30th opinion from slightly different versions of itself. It's pretty wild.
And then, it basically takes a poll of its own opinions. So if all 30 of those internal experts agree, like 95% of them say, yep, that's cancer type A, well then, the AI is super confident. But what happens if they disagree? What if half say it's one thing and the other half say it's something else? That's when the AI flags the case as uncertain. It actually recognizes its own internal disagreement.
What this whole process creates is an absolutely amazing tool for the pathologist. It's called an uncertainty heat map. It basically overlays the original slide with colors, showing the doctor exactly which parts the AI was confident about, and more importantly, which areas it found confusing or ambiguous. It's almost like a weather map for the AI's confidence.
Okay, so what does all of this actually mean in practice? Let's take a look at how this awareness of uncertainty builds a much safer and more useful tool for doctors in a real clinical setting.
And this really gets to the crucial point. The goal here isn't just about raw accuracy. It's about building tools that are reliable and trustworthy. You see, this new ability for the AI to just abstain on the tough cases, to basically say, I pass, that's a critical safety valve that's been missing until now.
And the research showed that this method works incredibly well. The AI was able to confidently and accurately handle about 80% of the cases all by itself. But that other 20%, the most ambiguous, the most difficult ones, those were flagged for the human expert. It strikes this really practical balance between automating the straightforward stuff and making sure a human expert is always looking at the toughest challenges.
And there are a few key reasons why this approach is so powerful. For one, it was designed to actually mimic how a real pathologist works. It was also tested really robustly on data from different hospitals to tackle that whole domain shift problem we talked about. And most importantly, it's built from the ground up for safety and interpretability. The doctor isn't just getting a blind answer, they're getting real insight into the AI's thought process. Now, this is a huge step forward for sure, but it's not the end of the story. Like all great science, this just opens up a whole new set of questions.
So let's look at some of the limitations and the really exciting future this kind of work points towards. Okay, so one key limitation is the type of uncertainty it can actually detect. This method is great at spotting what's called aleatoric uncertainty. That's basically confusion that comes from the data itself being messy or ambiguous. But it's not as good at recognizing epistemic uncertainty, which is when its own internal model, its own knowledge, is flawed. That's the tricky part, right? That's the AI not knowing what it doesn't know.
And on top of that, there are some other real-world challenges to figure out. For starters, running 30 analyses for every little tile, well, that's computationally expensive. It takes a lot of horsepower. And so far, it's only been tested on a problem with 2 possible outcomes, not on more complex cases with many different potential diagnoses.
But all of this really brings us to the ultimate takeaway here. The goal isn't to replace doctors. It's to build them the best darned assistant possible. An assistant that isn't just smart, but is also wise enough to know when to ask for help. It's about creating a true human AI team.
And that leaves us with one final thought to chew on. This research really paves the way for a whole new future of collaboration in medicine, and it makes you think, what do we really truly value in these powerful new tools? Is it just speed, raw accuracy, or is it maybe something more, something like trust? Thanks for watching.